Hello everyone, this is Teja from the second BTech IT. Now I am going to explain about travel salesman problem using branch and bound technique. The definition about travel salesman problem. It consists on finding the shortest single path that given list of cities and distances between them and visits all the cities only once and returns to the original city. Now about the branch and bound technique. It is a method for solving optimization problems by breaking them down into smaller sub problems. Now I am going to explain with an example. It is an example about travel salesman problem. Here I am having a 4 nodes and their weights. Now I am travel salesman problem with example. This is an example I am having with 4 nodes. This is an adjacent matrix for the above graph, and this travel salesman problem is solved by using the row reduction and the column reduction. First I am doing the row reduction. Now I am considering the least value in this row. In this row least value is 1 and in this row 1. In this row is also 1, in this row also 1. Now I am adding all these numbers, that is the 4. This is now the row reduction value is 4, and now I am subtracting 1 from this all numbers and I am getting this matrix. This is the column reduction value. Now I am calculating the cost matrix by adding both the column reduction value and the row reduction value. So this is the cost matrix I am considering with capital R. Now I am taking the starting node as A. Now this is the starting node. From this I am visiting the all nodes B, C, D. Now I am considering this starting node and this is the ending node. First I am traveling from A to B, A to C and A to D. Now I am considering the A to B. Now I am calculating the cost from A to B. So for calculating the A to B, I am making the Ath row and the Bth column as the infinity, and B to A value is also infinity. Now I am taking the remaining values from the this is the last matrix which we have calculated the cost matrix. And now by taking this matrix I am doing the row reduction for this matrix and considering the least value which I am having all the infinity I am taking as a 0 and calculating the row reduction value. Here row reduction value is 2. By subtracting all these values from this matrix I am getting this matrix, and I am doing the least value in this all columns and calculating this column reduction value. Now I am adding both these values. I am getting the R cap value. This is the 2. This is considering as a cost matrix of this, and now I am calculating the total cost of the path A to B is C of A comma B plus R cap plus R, where C of A comma B value is this 3 and R cap value is 2 and capital R is the cost matrix, that is 4, and total cost of this matrix path A to B is 9. Now I am taking the path from A to D. A has the starting node and D is the ending node. Now I am making the 8th row and the Dth column as infinity, and the D to A value is also infinity. I am calculating the row reduction value is 1 and the column reduction value is 0. So the value of R cap is 1. Now the total cost of the A comma D is 7. Now I am checking the least value in these 3 nodes, that is the C and D. I am considering C, and from C I am moving to B and D. Now I am calculating the cost of C, from C to B and the C to D. Now I am taking the path from A to D. A is the starting node and D is the ending node. Now I am having the 8th row and the Dth column as infinity, and the D to A value is also infinity. Now I am calculating the row reduction value and the column reduction value as a 1. Now I am finding the total cost of the matrix, that is the 7. Now I am checking the minimum value in these 3 parts, that is the A to C. Now I am moving from C node to B and D. I am checking these values. Now I am calculating the path from C to B. C is the starting node and B is the ending node. Now I am making the Cth row and the Bth column as infinity and B to C value is also infinity. I am calculating the row reduction value and the column reduction value as the 0. Now the total cost of this path is 7, and next I am taking the C to D path. Here C is the starting node and D is the ending node. C is the row and D is the column. So making the Cth row and the Dth column as the infinity and the D to C value is also an infinity, and calculating the row reduction value, that is the 2, and the column reduction value is the 1. Now the R cap value is the 3. The total cost of this path is 14. Here this is the 7 and the 14. In both 7 and 14, 7 is the list. Now I am taking this path A, C, B, A to C, C to B and C to B. Now B is the last node. Now B I am moving to D, and I am calculating the cost from B to D. This is the B is the starting node and D is the ending node. Now I am making the matrix from cost of B to D. Here Bth row and the Dth column making infinity, and calculating the both column reduction and row reduction, I am getting the value as the 0. So total cost of B comma D value, that is the 7. Now the last final path of the graph is A to C, C to B and the C to D. This is the final path of this problem. Now the basic applications of this travel salesman problem is planning, logistics and the manufacture of the microchips. And the advantages of the travel salesman problem is optimize and minimize the cost of the mile drivers, and main advantage of this travel salesman problem is delivery business and finding the set of routes to reduce the delivery costs. Thank you.